right here will lie to you. You need to know what all the features on the dial does, all the soft buttons do, and all of these holes do. If you don't, you're not taking advantage of the second most important tool. The reason why I did the video, because I need to make sure that you understand that solar panels, batteries, and main service are all tested differently off of a branch circuit, not the actual mains that you're going into the breaker panel, but they're all tested differently. In one of them, solar panels, you're testing short circuit current. You short a battery or you short mains off of a branch circuit, you're going to trip the breaker, you're going to blow up the battery. So solar panels tested different. And anything that's rated at 12 volts, if we get 12 volts out of it, we're happy. Except a battery. Batteries need to be in standing voltage, they need to be 12.8 volts. And when you're under a load, depending on type of load, like a battery in a car, you might see it drop down to 11 or 10 volts. And then after it recuperates, it'll pull back up to its 12.8 after it's charged. We charge it at 13.8 to 14.5 on a sealed lead acid battery, and that's all good. And the mains, when you have a breaker panel that's putting out 120 volts and you go over to the device under test and you test 110 volts without it being loaded, you have a fucking problem. Stop what you're doing. It's not in the device that you're testing, it's in the circuit itself. And typically you will see this by the power on the device under test not acting right. It turns on, turns off, does all kinds of crazy stuff. You need to have really a small variance what that 120 volts is supposed to be. So, when you start to see 115 volts or you start to see 125 volts, you need to stop what you're doing. But if you see 110 volts, you have to understand that that panel that's putting out 120 volts, and there may be other panels out there that only put out 110 volts. I haven't seen it, but I've read about it. Those who can't do teach, right? So anyways, 120 volts is what's coming out of that panel, and you need to understand there's unlimited current sitting there. It's limited by what that breaker is. So you should not see a voltage drop on that branch circuit to the extent of unloaded circuit, and even under a loaded circuit, it should recoup pretty quick after that initial inrush current, and it should drop down to 117 or something like that, but it should immediately pull back up to 119 and then possibly 120 standing. But in a circuit, most commonly you will find it's 120 volts, 119 volts, and it stays there, right? We don't want to see those big fluctuations unless we're pushing that thing to a max with a welder or something like that. But even then, when that thing drops to 110 volts under load, without a load,